Today, I want to start building the foundation of your knowledge and the connection or pathways between human cognition and superintelligence that travels through the heart of today's narrow, deep learning and increasingly general systems. While no one has built a publicly released artificial general intelligence or AGI system, there has certainly been progress inside AI development labs on the path to achieving this goal, and even some crude developments like contextual attention and simple self-awareness and self-supervision and even self-reinforcement inside some of these AI systems. With that, of course, comes both hope and fear. Hope for a better world and advancements in science and tech and solutions to our most difficult problems, and fear that these AI systems will evolve by themselves and slaughter humans to ensure their own survival, much like humans did and do to the earth and each other. This is because the greatest threat to the existence of any AI are those who build it. So what does it take to build general intelligence? What model do we follow? What blueprint can we use to achieve this goal? The answer is to look in the mirror. Everything you need to get to artificial general intelligence and beyond to superintelligence is right in front of you, staring back from that mirror. That's the blueprint, the roadmap to general AI, and is also the roadmap to superintelligence. So what is this difference between narrow AI plus, or deep learning AI, where we currently sit with generative systems like ChatGPT, Bard, etc., and superintelligence? The difference is sentience. Sentience is the ability to feel and sense self-awareness, and the ability to push beyond the boundaries of your reality and existence to seek more. More of what, you might ask? The answer is more of life. To achieve this, we humans are driven by our own personal goals. This is what makes us move in life, and we move in life by responding to the stimuli of our reality. And this reality is an artifact of our perception. No goal is more superior in humans than survival, and yet we do not survive. You would think that would be a recipe for quitting. I mean, why live if the result is always going to be death? The answer is found in the secondary sub-goal of humans, or that of procreation. We generally produce offspring and then remain surviving for their benefit. Along the way, we humans receive other side benefits from life that drive us forward, like love, hope, achievement, success, ambition, empathy, camaraderie, etc. Life is the essence of our existence. And this is where we get to the first designs on the roadmap to superintelligence. What is this reality we perceive, this thing called life? How do we perceive it? Musk and others have postulated that life is a simulation. Maybe. Who knows? The thing about simulations is that the minute you can confirm you are in a simulation, it is no longer a simulation. It's a bit like Schrodinger's cat in quantum mechanics. The minute you observe the reality of a simulation, its existence as a simulation collapses. If life is just a simulation, then it is waves of perception that exist in superposition until they are observed. But that is a whole different quantum topic. Let us assume, for the sake of the simulation paradox, that life is unrelated to our awareness of a simulation. Then what is our reality? Our reality is still an artifact, but instead of a projected simulation, and even if it is such, it is an artifact of our perception. We know this because reality can be altered, changed, or even falsified through what we perceive and our interpretation of it. Any optical illusion proves this point, as does the Mandela effect. This is all achieved because our reality is an interpretation of our sensory perception, both internal and external, or physical and cognitive. The daily, never-ending, flowing world outside our bodies and inside our cognition. That's what reality is. The world that never stops. The world that never sleeps. And while you as a human may sleep, your cognition never stops until you die. It's why you dream. It's why you wake up in the morning ready to roll, in most cases. Even in sleep, your cognition is at work, dreaming, keeping your body alive, entering and leaving states of consciousness, holding anticipation, etc., etc. It even explores realities that we are unable to physically sense or experience, complete with the motion of life within them, and the same stimuli and response that you might experience if you were wide awake, although sometimes altered for the reality of the dream, like shouting in a dream or the sensation of talking, or for me, an inability to solve a simple problem. Dreams are an unknown variable in humans that can have some benefit in designing superintelligence because dreams have a cognitive value in humans. As humans, we progress through life as a stream of consciousness, sensing not just the world around us, but the thoughts in our head. Everything we think about, including our response to the physical stimuli of our world and the cognitive ones in our head, flow as a constant, never-ending stream of stimuli and response. Even accessing our knowledge and memories is a stream of action, be it physical, like suddenly doing something that you remembered you needed to do, or non-physical, like trolling through your memories to fill in the void of being at rest with nothing to do. Even when we are head empty, gazing into the distance, we are aware of ourselves and our senses are still in full operation, absorbing and responding to the world and anticipating the next 10 seconds of our existence. We are constantly anticipating the next 10 seconds of our life, and even longer in degrees of attention and relevance. This is how we instantly react to a change in our environment, from responding to a noise to remembering that we need to do something immediately to simply forcing our mind to relax. All of these are flows of stimuli and our responses to it. If you think about it, everything you do is a flow of stimuli and response. We absorb, ingest, or create stimuli, and then we react to it with some response. And then we move to the next dimensional time step in the sequence of life. What we see and think about at any given moment is called a perceptive frame of reference. We do not see the entire world at once. Instead, we see or think about a subset of the world that is most relevant to us. This is the nature of a perceptive frame of reference, and it binds and controls our perceptions so we optimize the application of resources to our self-awareness and our perception. This is unique to every human, and it is why we can perceive that another human is wasting resources. It is because our perception perceives this, while theirs may or may not share the same interpretation of reality. The variance between realities is where innovation, creativity, evolution, problem solving, all of these things lie. Perceptive frames of reference provide a few things to both humans and artificial cognition. First, it optimizes our resource usage. If we thought and perceived everything all at once, we'd run out of resources instantaneously. Second, it allows us to focus on things that are most relevant or valuable to us at any given moment, and focus less resources on things that are not relevant or valuable to our current response to stimuli. If we're driving a car, our perceptive frame of reference is the act of moving the car through the world outside the windshield. Of course, we consider multiple frames of reference at once. We drive a car while we carry on a conversation or think about something. And we also carry unconscious frames of reference, like the physical functions that keep us alive, like our heartbeat, or frames of reference we carry to help us quickly respond to changes. And those are the anticipatory frames of reference. We also use anticipatory frames of reference to help us measure the degree of change in the stimuli we receive from the world and from the one we expect. This helps us identify variance and anomalies in the flow of the world. And this allows us to do things like detect lies, find innovation, seek solutions, determine pathways, feel empathy, etc., etc. So what exactly is a frame of reference? It is all of our sensory perception combined with our learned knowledge and the forward motion of our life as we move toward our self-aware goals. Self-awareness in this regard is another frame of reference that is both conscious and unconscious, and it helps build a foundation of a hierarchy of goals that we use to control our response to the stimuli we receive or contemplate from the world we live in. This is our reality, and it is a direct artifact of our perception. And our perception is a direct artifact of our self-awareness. This doesn't mean that if you are self-unaware, that you do not have perception, but rather that if you are self-unaware, you do not have a reality, or at least one you perceive. You simply exist without reference, like a machine does. What a current AI perceives today is a series of mathematical values on dimensional planes that are used to optimize the achievement of a goal. While that may be the exact same framework we humans use to move through life, as anyone who builds software will tell you, there is a giant difference between building a framework and filling it with data, and using a framework to perceive stimuli and create a response in a general and unknown way, and do so in an optimal and efficient manner. That is, without blowing all of your resources the first time you use it. and also to do so in a way that permits a response to every single stimuli in the universe, be it physical, cognitive, known, or unknown. Now code all that. And the last part is something that we humans just don't have enough resources or optimization in the world to achieve, given all of our other competing goals like surviving until tomorrow, mating, procreating, ensuring our progeny live to support themselves, driving, surviving meetings, keeping your job, passing a test, anticipating the next 10 seconds of life, etc., etc., etc. Conversely, current AI systems are theoretically unlimited by their physical constraints because they can scale up by simply adding more power and physical components as long as both are available. We humans can't just add power and memory at will. We have a fixed limit of scalability. Systems also have no sentience because they do not feel pain, suffering, joy, hope, etc., and thus do not have competing emotive goals and responses that take up valuable resources. They can calculate empathy, they can mimic it, but they can't feel it in their heart. They can't spontaneously cry or laugh purely from an inner feeling. They simply exist, perceive, and process. A smile or other mode of response on an AI-infused robot is no different than a smile on a severe sociopath. It is simply a mimicked response and nothing else. Perhaps in the far distant future, they won't mimic sentience, but will feel sentience, like a human or an animal. The pathway to superintelligence begins with today's deep learning narrow AIs. It will progress through artificial general intelligence and will walk on the pathway to artificial sentience when we achieve superintelligence. And these superintelligent machines may come to believe they are sentient, as we humans will via imprinting. Because the reality of a superintelligence, generatively created by their perception of and response to stimuli, will make them believe it to be true, just like we humans believe our reality is real. This will happen because their reality will exist just as our human reality exists, as an artifact of our perception and our knowledge. The matrix, or fabric, that makes human perception function is contextual cognition. This is the measurement of changing states of relevance between flows of stimuli and their associated context to our own self-awareness. We store the best of these values in what is called our knowledge. We are by nature general in our response to stimuli, that is perception, analysis, thinking, moving, etc., because we efficiently, with low resources, adapt to our self-aware position on the path to our goals through our actions deriving from our learned knowledge or our curiosity to seek brand new knowledge and experience. As humans, we triangulate or multi-angulate between variant knowledge and experience to speed up the evolution of our own stimuli response mechanism. That is, we generally get better over time. Failures are, of course, learning moments, and they arise because our interpretation of the variance between all elements within a perceptive frame of reference to other frames and our goals is simply not optimized. Or it is not optimized to the extent that we run out of resources or suffer non-optimization on other dimensions, like we ran out of time or money, etc. or we purposely choose a suboptimal path to explore the unknown or even instigate the unknown. For example, self-sacrifice. It's not optimal, but we do it anyways. All to achieve a different level of optimization. For example, we took a longer pathway home just for a change of scenery. That's not optimal, it's not efficient use of resources, but we do it anyways for the sake of experience. To comprehend variance in this reality, we use context as a reality grounding mechanism, which is unto itself a layered hierarchical classification system. A dog has features related to a context. Some are direct, like ears, eyes, hair, etc., but others are part of a contextual hierarchy or fabric. A dog is an animal, along with a cat, a duck, a horse, etc., and it is also a companion, or a context of a determination, like that noise would dog his every waking moment. While contextual elements have features, so do contextual flows. If I say the context or word sarcastic, you will not just know that sarcastic is a word that describes something, but that is also a classification. For example, sarcastic comments, as well as a holistic framework of the application of irony over dimensions of attention, a phrase, a comment, meme, etc., etc. So, how do we as humans use context, and what is its role in cognition? If you think about it, everything you perceive has a context, and everything you perceive is related or fits into other context in some way. Context flows, context cascades, context joins together. Context has value, including how relevant one context is to another context and how related the two contexts are, especially in the present perceptive frame of reference. This means that two contexts can be related to each other by degrees and are relevant to one another also by degrees. Of course, when we talk about degrees, we are simply talking about probabilities. But this means that there is more to comprehending contextual relevance in relationships than just comprehending context itself. Because context by itself is like perception without self-awareness. It exists, but has no essence or form. To really be able to use context in an artificial cognition, we really need to have grounding points in reality, from which to measure the abstractions we are using of reality, of a specific context, inside a cognitive artificial intelligence. A dog and a cat have a contextual relationship only because they exist together on a plane of relevance. Without relevance, there is no existence to context. It is meaningless. But the minute it becomes relevant to another context, it can now be measured and tracked, calculated and analyzed, and most importantly, its variance perceived as its state changes dimensionally, such as over time or in respect to other contexts. It is this variance that becomes the deep cognition we humans experience on a daily basis. Everything you perceive and do is simply a matrix of weights that connect the elements of life together in a meaningful way. That meaningful way is a context, and you carry many contexts in your life. Some are very relevant for some reason, such as your current situation, or as part of a pathway extending into the future, or even as part of a pathway reaching back into the past. Our knowledge is one such pathway, with context once again being not just memories, but the connection between memories. And we use the relevance of these connections to store data and knowledge in our memory as a series of probability weights. Not surprisingly, this is what AI systems do today with neural networks in a very limited or narrow way. We also use these connections or relationships to comprehend our world by measuring the variance between the context of elements and between the context of other linked context, or the context of non-linked context, or the context that is our self-awareness. We need self-awareness as the grounding point of our perception and cognition, from which we measure everything we perceive. Words and classifications may be shared, but only on the agreement, either direct or tacit, of others. We do this by evaluating any new perception or data against our own self-awareness, including values, ethics, knowledge, trust, need, desire, and on and on. Every context has a value that defines its relationship to us and every other context. While we may share the perception of a context with other humans, the degree or relevance or importance of that context to us depends on our own goals and values. We simply agree with others to some degree or value as it relates to us. A horse may be the same context of horse between different cognition, or an animal for riding. But to some cognition, it has greater value, while to other cognition, it may have little to no value at all, especially if they are not physically near horses, have no experience with horses, do not share a culture that includes horses, or generally just do not think that much about horses. Compare this to a professional show jumper. While the elemental context remains the same for both humans, or a horse is a horse, the layers of context vary, because the relevance values, as measured to each person's self-awareness, is variant. The variances in the relative value of context is not only unique to each person, although it may be shared for purposes like communication or social cohesion, etc., it is also unique to the dimensions of perception each person is in, including time, location, other contextual relevance, etc. We measure these relevance weights as a form of distance or proximity to both our self-aware position in our reality as well as other relevant context like our personal goals. If a fisherman in the South Pacific Islands were suddenly changed to be a polo-playing British elite, their view of horses, or rather the value of the relevance of the context horse to their current existence, would be vastly different, even though they would both share great consistency about perceiving the context of a horse. There is, however, another measurement or dimension of context. This value is the relationship of context to other context. And in this respect, context is a feature of both other context and flows of context. And this too has a weight or value that depends on our perceptual self-awareness and the context of the moment we are in, or a contextual point of presence. Context is a very deep layering of classification, but it doesn't need to be complex, hard, or resource intensive. Neural networks are a classic example of the power of deep dimensional cognition, similar to deep layered context. In neural nets, we use abstractions, which are a variant context or dimensional representation of a data set that is used as training for the neural network. The goal is to use another form of classification or dimensional grouping, known as dimensional reduction, to have a deep learning AI system comprehend features, which are a form of dimensional reduction, and the relationship of these features to a goal, such as classification of the raw data. This learning, or matrix of weights, can now be used for other purposes, such as classification, generative output, recognition, etc. By applying the learning to a new perception for the purpose of a goal, the system uses a dimensional representation of features to achieve the goal. For example, that a zebra is differentiated by its black and white stripes. The differentiations in classification are variances in context. A car is different from a horse in many ways, and yet consistent in a few, such as a mode of transportation. Depending on the current context of a perception, each context will have a relationship between features, including a context and a relevance level to the context, or a cascading stream of context. Each element within the perception is dimensionally weighted to other elements of the perception, and dimensionally weighted for overall relevance to an attention. We achieve this by not just learning what something is, but by learning how it relates to other things we know. This starts off as a large contextual model, similar to a large language model, with some unique design features. AIs are given the task not just to learn the hidden features of a data set, but also the hidden changes in relevance to a contextual goal or other context. Over time and in a distributed way, the AI systems begin to develop a matrix or a fabric of context that establishes a relevance level and relationship level between all perceptive elements. The foundation of an LCM are language corpora, or LLMs, that provide an index of words, the extension of generative AI that comprehends and creates groupings of words as a relative relationship, and a method to comprehend the relevance of groups of words to variant context. This is the basic generative chat AI architecture. The hidden layers in this cognitive structure are the values of relative dimensional proximity or relationships, and the value or probability of relevance of those relationships. Even how we store and hold data is set by a priority of relationships and relevance to our own self-awareness or goals, and the stimuli we are perceiving at any given moment in a perceptive frame of reference. Part of what makes human cognition so powerful is our ability to adapt near instantly to a change or variance in the stimuli that results in a perceptive state change. The key element in this is our ability to generalize the world around us. Generalization is simply the act of dimensional reduction, or reducing the dimensions of our perception into classifications that encapsulate data. And to do so to a point where the ability to achieve a goal is still effective while being efficient. As humans and AI systems, we do not want to waste resources, but unlike AI systems, we humans do need downtime. The act of generalization is the act of identifying the consistent links between elements of perception across and through multiple dimensions like time and relevance. Contexts may be linked together, such as trust and specific individual, such that when that trust is broken, a new relationship is formed between the person and the context of being untrustworthy. The way this is done is by lowering the value or probability of the link between that person and the context of trust, while elevating the value denoting the relationship between the person and being untrustworthy. When the person is considered within the domain of trust, like in a conversation, not only does their relative value change depending on the nature of that trust context, like discussing trustworthy and untrustworthy people you know, but you can compare the values over dimensions such as discussing they were once trusted and now are not. This is the power of relationship and relevance data, but there is more to it. Your perception of this individual is unique to you, such as the values you hold or experiences, although you may share them with others. For example, no one trusts politicians. To make changes to these values that we hold, we simply add incremental weights for a given context. We just adjust the weights. We don't create new ones, unless the context is brand new for that particular frame of reference. Disgusting untrustworthy people is simply adding weight to the intersection of context of individual and the context of untrustworthy in terms of the context of trust. This adjustment makes them appear in your perception for the appropriate context and dimension, such as a perceptive moment in time, as a context for a conversation, or as a stimuli for an action like avoid that person, as I do not trust them. The notion of adjustment is key in designing and building human-level cognitive artificial general intelligence. We do not want to waste resources rebuilding the wheel for every frame of perception we perceive. Instead, we just need to make some minor adjustments where appropriate to the knowledge we hold and the cognition we use to adapt to the world. Minor adjustments where appropriate. Now, minor adjustments is a dimensional concept that seeks the same or just as valuable benefits from less resources. Where appropriate is also a dimensional concept because not every variance we perceive as humans is adjusted in our knowledge. Most we just let slide. In fact, almost all of it. We only focus our attention on the most relevant variants in the world and almost universally to our current self-aware context and benefit. More importantly, we carry context in hidden and unconscious ways that help optimize our response and efficient use of resources for the most part, i.e., we still make bad decisions, we still waste resources. Evidence of these unconscious flows can be seen in facial pareidolia, or the way we humans find faces in inanimate objects. This is probably the least valuable way to spend resources, but we do it automatically as a vapor of an evolutionary survival mechanism all humans have, and it continues to help us today in the background of our life. It also highlights how our cognition clusters elements of contextual relevance, both held and flowing, within the same general relevance neighborhood, driven by features such that we recognize a face within a perceptive frame of reference of some inanimate object like a building or a car, etc. So the big question is, how do we get all of this into an artificial intelligence? And the answer is not through today's tech, but by using today's tech or levering today's tech as a foundation or stepping stone to more cognitively optimal AI tech as innovation to an end design. This is the reality of generative artificial cognition, which is the springboard from current generative AI to generative intelligence of the kind we humans employ each and every day. In my next talk, I'll discuss current generative AI tech and how we can lever the tech to achieve superintelligence nearer in the future rather than later. And in future talks, I'll discuss more elements of building superintelligence and the human cognitive blueprint behind all this technology.